Hello everyone and welcome to the second video of this series about working on the project of my own functioning GLaDOS miniature. Last time I implemented the foundation of the new program that will be used to control everything further down the line. In this video I want to build upon the new foundation and implement one key feature that was also present in the old temporary program, voice recognition. This will enable me to easily control the states of the program with my voice instead of typing in commands on a keyboard. Before discussing how I want to implement the voice recognition, I quickly want to go over the requirements that need to be fulfilled to reach the goal of this video. The first requirement is the overall foundation of the program. This was achieved in the last video and will be used here. The second requirement is a library for voice recognition, as I am not in the mood to create a voice recognition completely new from scratch. This is also already fulfilled, as I will use the same library that I used in the old program. The third requirement is to narrow down which commands should be used in which context. This will be done in the next chapters of this video. With the requirements out of the way, let me guide you through the design of concept. Thanks to the first video, I will skip over a lot of things regarding the program itself, as the design has not changed since the last time. Instead, I will only focus on the necessary components. The voice recognition is an independent component of the software and will communicate with other components as inputs will come. To implement the basic voice recognition, I will need to implement and modify the components GLaDOS, Auto, and Voice Recognition Manager. The first two will be extended by state machines for handling dialogues and different inputs. The Voice Recognition Manager will be implemented as a new component. To get my command via voice input into the program, the Voice Recognition Manager needs a new component for the library for voice recognition that I will use. I decided on using the library CMU Sphinx 4 since it worked okay the other times I have used it. Please note that this library is apparently not up to date anymore and will likely be replaced at some point, but for now it will do. This library uses the microphone to extract commands from a defined grammar from speech input. This means that this voice recognition is not broad like your smart assistant like Google or Alexa, but localized and narrow in its capabilities. The grammar file also needs to be defined by myself for the commands that I want to use. When an input via speech is detected, the Voice Recognition Manager will decide where this input will go. The current two choices are GLaDOS and Auto. To decide where the input will go, I simply set the dialogues to always start with a key phrase like "Hey GLaDOS" or "Hey Auto". This input is then processed in GLaDOS and Auto with the help of state machines. As a quick explanation of state machines, a state machine is a defined set of states that will change when defined conditions are met. For example, vending machines are often state machines and will only do something if an input is given. These state machines need to be constructed for each dialogue path of the voice recognition. To keep things under control in this video, I focus on the bare minimum like shutdown, reboot, or just simply saying hi. Other paths will be appended in the same fashion here when other features are implemented. Each state machine is designed so that it can be aborted at any point, meaning the program will not get stuck in some dialogue path and can always be returned into the default state. Another note here, when one dialogue is engaged by speech, all other dialogues will not be accessible. This is implemented to avoid complications and conflicts between different dialogues. The UML from last time was adjusted with these design choices and can be seen here and will be used for the realization in the next chapter. With everything of the design choices explained, I will now move on to the realization. The realization in this video will be quite short, since I do not want to go into the depth of the code, but here are some notes anyway. I implemented everything in Java version 8 as last time, and if you want to know more about the program code, check out my GitHub linked in the description below. With the coding out of the way, let me define and do some tests and a demonstration. First up a quick note, the test will not be done on the target hardware as it makes things more easy for me. The capabilities of the overall program will be skipped since they were demonstrated last time. This chapter will focus on the different dialog options that are currently implemented. The tests will show how the program can be manipulated with speech input. The response of the software components are shown in the console, as the sound output is not yet implemented, but the required packages are already being sent by the program. This part of the demonstration is actually live and not edited to show you the behavior of the program. And if I hit run here, you can see that the program is running. Hello Auto. Hello GLaDOS. Hey GLaDOS. Abort dialog. Hey Auto. Reboot. No. As you can see, if I talk freely, the voice recognition tries to recognize the defined grammar into my words, And this is why I implemented the keyword system to avoid having problems with random commands. No, actually it didn't really recognize that much. Here it got high GLaDOS, but I didn't set it. Anyway. Abort dialog. Hey auto. Shut down. Yes. And there you can see the program is now stopped. With the tests done, I want to quickly sum up everything that was covered in this video. First, requirements were set on how the voice recognition for GLaDOS should be reworked and implemented. After that, the new systems to achieve the goal were explained. The realization led to tests to show the behavior of the voice recognition purely with defined grammar and with free speech. As last time, I decided to visualize the progress in form of a skill tree where individual nodes represent one feature. With the end of this video, the next 2 nodes are finished. These nodes represent the overall program part for voice recognition and the specific implementation of the voice recognition with CMU. Next I will work on the sound output to be finally able to really talk to Auto and GLaDOS again. The last video was uploaded some time ago, since I was quite busy with my studies, but I definitely will continue to work on this project. The progress might be slow, but it will be somewhat consistent throughout the next years. The time required for the single components will of course vary a lot, since I often find myself to work on other projects. The program for this video was actually almost finished in February 2022, but then I got lost in another project that will be covered on this channel at some point, and simply did not have the time to work on this project too. With that out of the way, thank you for watching this video and see you in the next one.
Is he away?
Human presence not detected.
Good. Contact me, my new testing subject.
Informing robotics facility.